Okay, in this next part, let's look at how to find exact values using the periodic properties. Now, this is our first example. If you're given cosine of 33 pi over 4, when you look on your unit circle, this is clearly not going to be on there. So I go off to the side and I say, well, 4 goes into 33 about 8 times with 1 left over. So we're going to say 8 pi is the top, and then 1/4, which is just your pi fourths, is going to be what's left over. So this is writing it in that format as the theta plus p. And remember, we can ignore this periodic part and just evaluate f at theta. So that's what we're going to do now. So I figure out that this periodic part is 8 pi, so I can just evaluate it cosine of pi fourths, look on my unit circle, and I get square root of 2 over 2. Which I pulled up a unit circle. So pi fourths is right here. The cosine value is your x square root of 2 over 2. Okay? Sine of 9 pi over 4. Well, 9 pi over 4 is not on my unit circle, so I come out here and divide and I get 2. So that's where this 2 pi comes from. And my remainder is 1 over 4. It's not the case all the time, just so happens to be in this. So that's my theta. Okay, so we can ignore the periodic part and just do sine of theta, which is the sine of pi 4. So we come over here to the y value, which is the square root of 2 over 2. Okay, one more right here. So if I give you the tangent of 19 pi over 6, okay, I divide that out and I get 3. This is 3 pi. Now this didn't have to be an even increment because remember, tangent and cotangent are the only ones that have a period of just pi, so it's okay that this is just an odd number of pi. With 1 left over 6, so that's going to be pi, 1 pi over 6 plus the 3 pi that's periodic. And that's going to be the same value as me evaluating the tangent of pi 6. Tangent of pi 6 is over here. I have it highlighted. The tangent's going to be your y value, 1/2, over your x value. Multiply by the reciprocal. We get 1 over the square root of 3. We'll rationalize our denominator by multiplying both sides by the square root of 3, and it simplifies to the square root of 3 over 3. Okay, the next thing, find exact values using periodic properties, but it gives it to us in degrees. Well, it's kind of like what we did when we were working with coterminal. We would do 405 is clearly not on the unit circle, so we would subtract one revolution out, 360 degrees, and that would just allow us to evaluate sine of 45 degrees, which, if we look back at our unit circle, it's the square root of 2 over 2. Sine of 45 right there, bam. Okay, and then now we come over here, cosecant of 450, we want to take one revolution out, and we're looking at the cosecant of 90 degrees. Okay, so we go to the cosecant of 90 degrees right here, and it's going to be 1 over the y value, which is just 1 over 1, which is 1. Remember that the sine and cosecant have a period of 2 pi, or 360 degrees if it's given in degrees. Alright, so here's just a rough example. It tells us if sine of theta is 0.5, find the value of this. Now, what we want to know here is this information they gave me. And remember, this is periodic, so theta plus p. Well, if it's plus p, we just evaluate sine of theta. Sine of theta is 0.5 again. This one's periodic, so we just have sine of theta, so you would just get 0.5 plus 0.5 plus 0.5 is going to be 1.5. Now you can either print these videos, notes out, or you can pause the videos and write the problems down as I work them. Alright, we talked a little bit about this, the signs of trig functions in each given quadrant. Remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. all 6 trig functions are positive here. Sine and its reciprocal are positive in quadrant 2. Tangent and cotangent, cosine and secant. Okay, all students take calculus. That's what helps to remember that. So let's see some examples of working with this. Name which quadrant angle theta lies. And so all you'll be given is this black information. They'll tell you the sine of theta is greater than 0 and the cosine of theta is less than 0. Now what we have to figure out, anything that's greater than 0 is positive, so I put myself a little plus sign. Anything that is less than 0 is negative, so I put a negative sign. Now I'm going to come work with this one. And I'm going to say sine is positive in quadrant 1 because all of them are positive in quadrant 1, and positive 2 because that's where S is. Alright, cosine is negative, not negative, they're positive here, so that means it's negative over here. So put the green ones where it's negative, where it meets this stipulation. So the quadrant in which it meets this criteria and this criteria is going to be quadrant 2. Okay, the next one, sine is less than 0, remember, so that's going to be negative. Tangent is less than 0, so we want to know where it's negative and negative. So the sine value is negative. If it's positive here and here, that means it's going to be negative in these two quadrants. So the purple check means it satisfies this condition. If tangent is negative, well, it's positive here and here. That means it must be negative in the other two. Well, then we're looking for the quadrant in which it meets both of the purple and the green. That's going to be quadrant 4. Okay? Our next example is when our cosecant is greater than 0. That means when this one's positive and when the cosine of theta is less than 0, so when that one's negative. So we make those comments, and the cosecant's positive here and positive in all, so that's the two purple checks. Cosine's negative here and here, so they overlap and meets both criteria in quadrant 2. Okay, so that's just practicing quadrants with location in quadrants. The next thing you're going to do is your reciprocal identities and your quotient identities. And we've talked about reciprocal identities. Cosecant's the reciprocal of sine, so we would do 1 over sine. Secant, 1 over cosine. Cotangent theta is 1 over tangent theta. The quotient identities are going to be tangent theta is equal to the sine of theta over the cosine. Cotangent is the cosine over the sine. Okay, so you want to definitely pause the video and write down your identities. Okay, these are the same, fundamental identities. These are all considered your fundamental identities. Reciprocal, quotient, and the Pythagorean identities, these are the ones with the squared. Sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. And we can solve for secant squared theta, tangent squared theta by subtracting 1 from both sides. So we can solve for different variables, so to say. Cotangent squared theta plus 1 equals cosecant squared theta. These you want to make sure you write down, maybe make some index cards for so that you can study these and know these. So pause these and make sure you get all of them written down. Okay, one of the things you'll be asked to do is they'll say, if sine of theta is negative 3/5 and cosine of theta is 4/5, find the remaining trig functions.